Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is find anagrams in linked list, and it is a medium level problem. So in this particular problem, they say that we have been given a linked list containing a string, right? So if this is the linked list, at each particular node, a, a character will be present. So it will totally form a long string, and we have been given a separate string s as well, right? And we have to return all the anagrams of the string present in the given linked list. So for example, if BAC is the string, anagrams of BAC are any arrangements that can be made using these three letters, and no other letters should be used, and the frequency of those letters should be the same as well, right? So it's just that their permutation can be different. So in case of overlapping anagrams, choose the first anagram from the left. So they say that if this, in this example, let me just show you. This is the test case that we have. So for example, in the first test case, when we have the overall string A, B, C, A, D, B, C, A, right? So when we have this, what happens is the given string is BAC. That means we can form any permutation using these three characters ABC, and their frequency should be the exact same. If we have got 2A, 1B, 1C, then we can form any anagram like this or this, right? Just their order can be different, but the frequency should be same. Now, while using these three characters ABC, one anagram can be formed like this, which is ABC, and one can be formed like this, which is BCA. Both are anagrams of BAC, that is the given input string. So this is the given input string. Now, in this particular case, since they are overlapping, the question asks us to, like, what we have to do, we have to take the leftmost, right, which is starting earlier. Now this particular hint like makes the problem a lot easier, and we don't have to worry about certain things, and the rest of the problem can be solved easily with 2 pointers. I'll explain you how we can solve this problem with 2 pointers. So for example, if I have, let's say, some character C here and some character D here, and I have one pointer here and I have one pointer here. While I am having these 2 pointers at two different places, I'll be maintaining an array or a vector of size 26. So this will be an array, let's say it is of size 26, representing all the 26 characters of the alphabets. This is my current vector, and a similar vector will be an original vector. So original vector will store the frequency of all the characters that are being given in the input string, right? This would be an identical vector of 26 size and will store the frequency of all the characters that are being given in the input string. For example, in this case BAC was given, so the frequency of A would be 1, the frequency of B would be 1, and the frequency of C would be 1 in the original vector. Now the current vector will store the frequency of all the characters that are in this particular range between C and D, between our 2 pointers, including both of the pointers, right? So this is how our workflow will look like, right? I have two vectors, current vector and original vector. Now let us discuss some cases, right? So case number 1 is, let's say, for any of the 26 characters or for any of those indexes from 0 to 26, right? So for any of those 26 characters, if current of I is greater than original of I, so this is the first case that we are going to discuss. Now in this particular case, what happens is, for example, if we have been given ABC, right, and let's say this is the sample test case, and we have A and B here, right, and we have our 2 pointers like this. This is just an example. So in the original vector, the frequency of A would be 1, the frequency of B would be 1, the frequency of C would be 1. But in the current vector, along with ABC, frequency of D is also 1. So in this particular case, at index D or at the third index, starting from 0 at the third index, current of 3 would be greater than original of 3, right? So this means we have encountered one such characters among those 26 characters such that its frequency is greater than the original string. That means this this particular range cannot form the original word now, because one character has exceeded the limit of characters, or the limit on the frequency of characters. So now what we have to do is we can move the left pointer forward. We have to move the left pointer forward, and as soon as we move the left pointer forward, we have to do two things. So earlier the pointer was at C, we have to decrement the frequency of C by 1, and now the pointer moves forward, right? Only after decreasing the frequency of C, we will move our pointer forward, right? And there is one more special case in this particular scenario, when the left and the right pointer are pointing to the same element. So let us just go through this dry run only. So when in this particular case also, if you see, when the pointer is at A, right, still the frequency of D is great in the current array is greater than the frequency of D in the original array, because it is 0 in the original array, right? So now again I decrement the frequency of A, so this also becomes 0 and the pointer moves forward. Again the frequency of B is 1 and D is 1 and D is 0 in the original array. So again I decrement the frequency of B, that is the current element, and I move my pointer forward. So now you see that the left and the right pointer are pointing to the same node. So what we do is we take both of them and move to the next element, right? Also while decreasing the frequency of this particular element, right? So this was the first case, and in the first case also there are two specific cases when left pointer is less than right pointer and when left pointer is equal to right pointer, right? So in both of the cases you have to do plus plus left pointer. That means you have to move the left pointer to the next node, and in this particular case specifically you also have to do plus plus right pointer, right? So this was the first case. Now the second case is for all indexes. Like, this is very important. In this particular case it was for any of those indexes if current of I is greater than original of I. Now for all indexes, if current of I, indexes means all the characters, that is from 0 to 26, right? If current of I is equals to the original of I, right? So in this case what we'll do is, it means that all the characters in the current array have the exact same frequency as all the characters in the original array. That means we have found our string. In this case what we'll do is, we will reset our current array. First of all, reset current array. That means set all the values in the current array to 0. The next thing that we have to do is plus plus right and left is equals to right. So these are the three things that we have to do. Now I said earlier, where it said that we have to ignore overlapping anagrams, is very important and it makes our problem easier, is because now I can just move my left pointer to the right one, right? For example, if the initial pointer was here and the right pointer was here, right? So what happens is, I have found my anagram CAB, which is an anagram of ABC. Now I don't care if an anagram starts from this particular position or this particular position, because I have to ignore overlapping anagrams, right? So I can just ignore them and move both of my pointers to this particular position. Otherwise, if you see in the example, what I would have done is, or what I will have to do is, instead of moving both of the pointers to here, right, this is the case right now, I'll have to move A to this particular pointer and this will remain as it is, and then this anagram would also be considered, right? So this will lead to an additional case, but right now we can just ignore it as the problem statement says it. So when for all indexes this particular current of I is equals to original of I, that means we have found our anagram and we can just reset current vector to all values to 0. We can increment our right, and before assigning left to right, what we can do is we can just store the left in our answer. So answer dot push back left. Let's say we have done this, right? So after all of this is done, it means we have found our current, we have found our anagram and we have resetted our current vector. Now the third and the default cases, right? For in this particular case, for some of the values, for some there might be that current of I is equals to original of I, Like this might be the case. And for others, since all of the values are not equal, that means in the other cases, current of I is less than original of I. Why only less than? Because if it would have been greater than, then it would have been covered in the first case, because here I mentioned for any of those indexes, right? That means for others are definitely less than original of I, right? In this particular case, what we do is, it's just simple. It means that, for example, this is our original string and this was the input. So we were traversing through this particular linked list. Now, for example, if the pointers are like this, it means that I have partially found my string and I am on the right path. If you consider case 1, that means you have found some of the strings but you are on the wrong path, since some of the indexes has frequency greater than the original vector itself. But in case 3, what is happening is, some of them might be equal and the others are definitely less than. So that means we are on the right path on finding our anagram. So in this case, we don't do anything. We just simply move our pointer to the right. Right. So this is the important case number 3, in which for some the frequency might be equal and for others the frequency might be less than the original array. So in this case, we just moved our pointer to the right and consider our next element. For example, if it was initially at A, so the frequency of C was 1 and the frequency of A was 1. For others it is 0, right? And in this case, B is also 1. That means B is still left. So we move our pointer to the right. Now we have found B. We increment the frequency of B. And now it is an exact match. And now it falls under case number 2. So in this case, when for some of the indexes it is equal and for others of the indexes it is less than, the current of I is less than origin of I. That means we can just increment our right pointer, plus plus right. So in the code, you're not actually going to do plus plus right. We are going to do right is equals to right dot next, right? So this is a linked list, hence we are going to do that. Otherwise, if it was in vector, we could have just done plus plus right, right? So this would be the cases, all the 3 cases that we have to consider. There is one more very important thing, like if you, for example, if you are going through a while loop, traversing through all the vectors. So initially what we do is we just increment the frequency of the right pointer. Right pointer means, for example, if I am pointing to this particular node, I have to increment the frequency of B, the value that is stored in that particular node, right? So I have to increment its frequency. But there's one more important thing that we need to consider. There might be some cases where I don't increment my right pointer at all. So for example, in this particular case, right, in this particular case, when we were just incrementing our left pointer. So we have to take care of this thing also, that when we don't increment our right pointer, we don't do this thing. We don't again add the same element. For example, if this was the case, initially I have explained this case when one pointer, left pointer was at C and right pointer was at D, right? So when this particular pointer moves to A, what happens is we don't have to increase the frequency of D again, right? So we have to take care of this thing. Now we can form this 3 cases with the help of some status codes. Like I can just initialize my variable or a flag variable, you can name it anything. For example, I have initialized my variable called status. Now status will store the information which of the 3 cases have been formed in the current scenario, right? And according to that code, I'll be implementing one of those 3 things. So this is the whole approach of this question. Now let me just quickly go through it again. So this problem we will be solving with 3 pointers approach, and we will be storing a frequency array of the current elements and the original array or the original given input. Now at like whenever for any of those indexes current of I is greater than original of I, that means we have exceeded the frequency for any one of those 26 characters. That means we are on the wrong path and this particular string cannot form an anagram if we keep adding characters to it. So what we do is we just try to remove characters one by incrementing our left pointer. But if it is a case that both our left pointer and right pointer are pointing to the same node, then we have to increment both of those at the same time, right? Now case number 2 is when for all of those indexes current of I is equals to original of I. In this particular case, that means we have found our final anagram. So what we can do is we can reset the current vector. We can set all the values to 0. We can push our answer in our answer vector, and in this case the answer vector would be the left pointer, because from the left pointer the anagram is starting. Now we can increment our right pointer and we can set our left pointer to right. We are only able to do this particular thing only because the question has said us to not consider overlapping anagrams, right? Now the case number 3 and the final case is when for some of the indexes current of I is equals to original of I, and for other of the indexes current of I is less than original of I. That means we are on the right path and we can still keep on adding some characters. That is why we increment our right pointer, right? So this would be the explanation of all the 3 cases that we can consider while forming the answer for this particular problem. Now let us have a look at the code and you will get to understand this problem better. So whenever like the function starts, what I do is I form a vector, two vectors actually. So one of this, it is the original vector and the second one is the current vector. So original vector will store the frequency of all the characters present in the given input string. So I'm just incrementing the frequency of all the characters. Now I take 2 pointers left and right and I initialize both of them to my head, and I also initialize my answer vector which will be storing nodes. So we actually have to return nodes, node pointers, right? A vector of node pointers. Now this particular boolean variable take will store whether I have to take the element or I have to consider the element at the right pointer. So we only have to consider the element at the right pointer when the right pointer has been incremented in the previous iteration. If the right pointer was same in the previous iteration as it is in the current iteration, then we don't need to consider the current element, right? So that is why I just make sure that I can take this element and the right pointer is not equal to null. Only then I will increment the frequency of the data at the right pointer, and I set my take is equal to 0, right? So I've initialized my status with 1. So I have some status codes. So status 1 means case number 2. So this will represent case number 2 as I've explained in the explanation. So this will be the case number 2 when status code is on. Let me just write it also here. When all the frequency of the characters is exactly same as the original array, right? So this is the, now I just traverse through 20 to 26 characters, and if current of I is greater than original of I just set the status as -1. So in the status -1, I'm considering case number 1 when I have to increment the left pointer, right? And if current of I is less than original of I, this is when I set my status as 0. So this is case number 3 when I'm on the right path and I have to increment my right pointer. So if you see carefully all the statuses I have written. So in case number 2, what I just do is I just push back my answer and I set my right is equal to right dot next, right? And I set my left is equal to right also. So since I am incrementing the right pointer, I just reinitialize take with 1 or take with 2. And for all the 26 values, I just set a current of I is equal to 0. Now in case number 1, as I've explained, I increment my left pointer, but before incrementing it, I'll just decrement the frequency of that particular element at the left pointer. Now after incrementing it, I just make sure that if left pointer is equal to right pointer, then I also have to increment the right pointer. So right is equal to right dot next. And since I'm incrementing the right pointer at the same time, I also initialize my take with 1. And as usual, left pointer has to be incremented as well. So in case number 3, I just increment my right pointer, and in this case also I initialize my take with 1. So the only case in which take is not initialized to 1 or take is not set to true is when only the left pointer is being incremented, right? Whenever the right pointer is incremented, I can initialize my take with 1. So after all this has been completed, I have the nodes in from which the anagrams will start in my answer vector. But the problem is the way they are printing the answer vectors. I'll show you. So they have this function called print list. So whenever you pass a node, in this case we will be passing our left nodes, right? So they just print the whole linked list starting from the left node, right? So this is not what we want. We just want our anagram to be printed. So for each of them, I have initialized one for loop. For example, the size of the node for the size of the string is 3, or the input string is 3. So let's say in this case the input string was ABC, let's say, and for example our linked list, our anagram was like this. So it is like this, and then this, and then some other characters, right? So the size of the string is 3. I have stored this particular pointer in my answer of I, right? So answer of I stores the address of the first pointer. where the anagram is starting. Now what the their code does is they just print the whole linked list, but this is not what we want. We want only the linked list to be printed till here. So what I can just do it, I can assign my current variable to this. Since my length of the string is 3, I can just jump 2 times. So one time will be here and the second time will be here. And I can just set the next of this particular variable or this particular node as null pointer. So this linked list will be restricted to this particular area only. Now I don't care what happens to the original linked list because I don't need it further, so I can do this particular operation. Or the other method could have been to create a copy of all the elements, but we don't actually need it and it will consume extra memory, so we can just modify the original linked list and we can just break it because we don't need it anymore, right? But if you still want to save the original linked list, what you can do is you can just assign or copy or create a new copy linked list. So I've just modified the original linked list only, and at the end, since I can show you that s.size -1 jumps has been done, and at each jump the simple it is current is equals to current.next is like done. And at the end, after doing n-1 jumps where n is the size of the string input string, I just set current.next is equals to null point. Right. So after all this has been done, I can just return my answer, and this would be the solution of today's problem of the day: find anagrams in linked list. So this problem, like this is just the code is just a bit lengthy just because this is being performed in a linked list. If this was an array, this code would have been shorter. So I hope you guys were able to understand the solution. If you guys did, then you can show your appreciation by clicking on the like button. And a small notice that a lot of you who have been watching these videos have not subscribed yet. So you can subscribe to this channel. It's always free of cost. And if you don't find the content interesting later, you can always unsubscribe. So till the next video drops, keep coding, stay safe, bye bye.